So today we're going to be talking about solving problems with triangles by writing a proportion. One of the things we're really focusing on this unit is triangles, if you haven't noticed. And we use triangles all the time in architecture, in landscape, in surveying. It's really a lot of what our buildings are built upon is triangles and planning and mapping and a lot of that kind of stuff. And we're going to be studying some trig. But one of the first basic ways that we used triangles to help us solve problems was with similar triangles. And if you remember, a similar triangle are triangles that have the exact same shape, but they may be different sizes. So all their angles are equal, but not all their sides are equal. They have the exact same shape, but they're different sizes. And when we have triangles that are different shapes, or different sizes, but the same shape, we can write a proportion to solve for missing sides. If you remember, a proportion is when we have one fraction equal to another fraction, okay? And then we solve these by cross multiplying. And so if we have, for example, our large triangle here, and we know that it is similar to our smaller triangle here, what we can do is all the sides then have a corresponding side. They're not the same length, but as far as the shape of the triangle goes, this side A here goes with this side A here, and this side B here goes with this side B here, and this side C here goes with this side C here. And that's actually how we build our proportions. We match up sides from the two triangles, and they all have the same proportion. So whichever sides we happen to know, we can use them to solve for the sides that maybe we don't know. So let's look at an example problem real quick where we just set up the proportion. So if we have that this side is 12 and this side is 8 and this side is 3, and we want to know what this side is. So we're looking for proportion. So again, I want to match up sides. So I notice that this side goes with this side. So I'm going to say x goes with 8. Now, when you're setting up your proportions, it doesn't matter which side you use first in your first fraction. What does matter is that if I started with the smaller triangle on the top, I have to make sure that the smaller triangle is on the top on this side as well. So this side 3 matches up with this side 12, so I'll make sure that I put the 3 on the top and the 12 on the bottom. So you do want to be consistent in that respect. Whichever triangle you start with on the top on one side, it also has to be on the top on the other side. So now we just cross multiply and solve. So x times 12 is going to be 12x, and 8 times 3 is 24. And now we have a nice simple one-step equation. To get x by itself, I can just divide both sides by 12. My 12s will cancel out, and x is going to be equal to 2. So we know that that missing side of the triangle is actually 2. Now what you're going to find is usually we use this for word problem type situations, actual application problems. So let's look at the following situation. John is trying to find the height of the school. He goes outside at 2:00 p.m. and measures the building's shadow to be 64 feet. He measures his shadow to be 6.5 feet, and his height is 6 feet. Find the height of the building. Now, for these type of situations, you guys know that I love to use pictures because I've got to see things. So I'm going to have to draw a picture. So I have a building. This is Miss Parker's attempt at a building. So we've got some windows in our building. And he goes outside and discovers that the shadow for this building, so it's casting a shadow. It means the sun's up here somewhere, right? Alright, and the sun is casting its rays down to the ground, and then we end up with this shadow down here on the ground. And we know that he measured the shadow to be 64 feet. And then John also took his own height and his own shadow. And the beauty about living on the earth is the sun is so far away that if you're standing within a couple hundred yards at least of something, the sun is at the exact same angle as you. And so that's very important. because this sun is at the exact same angle, that means that this angle and this angle are going to be exactly the same in John's shadow triangle. And because those two angles are the same, that means that the third angle also has to be the same. And that's what makes them similar triangles. They do have to be similar triangles. They do have to have all the same angles, or it doesn't work. But because we have that piece of information, we now know that his shadow is 6.5 feet, and we know that John himself is 6 feet. And so we know two sides of this triangle. This triangle is similar to this triangle. We just don't know how tall this building is. We can now set up a proportion. We know that our proportion is going to be one fraction equal to another fraction. Which side goes with which side? When I've drawn a picture, it's real easy to see that. The bottom side goes with the bottom side, and the height side goes with the height side. We just want to be consistent. So if I have my x here, it's going to match up with John's height, 6. Started with this triangle first, so I've got to put that on the top over here. So this 64 is going to go along with this 6.5. So all we have to do now is our cross multiply, and we should be good to go. So we're going to have 6.5x is equal to 64 times 6, which is 384. One-step equation. Let's just divide by 6.5. Divide by 6.5, and we get 59.1. So the building is roughly 59.1 feet, which is very handy because, as you can imagine, it would be very complicated to measure a building, to stand on the top and drop a measuring tape down to the bottom. They don't make a lot of measuring tapes that you want to be dropping off the top of a building. So this is much easier to measure his shadow and his height and then the shadow along the ground than it is to be going somewhere trying to drop things off the roofs of buildings. And so this is how we write proportions and how we use proportions to help us solve distances. And hopefully, if you have any questions, you can ask me tomorrow.